Hello, good morning everyone. Am I audible? Am I audible to you? Good morning. Voice coming? Is my voice coming to everyone? Good morning. Voice okay? Am I visible? Okay, very good, very good. Good morning everyone. Good morning. Yes. Good morning. So let's start again. Okay. We were trying to learn about physics. Basic maths was going on in the previous classes, and we have covered graphs. Yes. Good morning, everyone. Good morning. Good morning. Good morning, Kirti. Good morning, Preeti. Good morning, Chintu. Good morning, Mahesh. Very good. Okay. So every day I used to write this AIM NEET 2024 here to remind you that we need to be focused for our aim. Our aim is to get selected in NEET 24. So every day remind yourself about your target, that why you are preparing, why you are working hard. Okay, remind yourself, then start for your achieving your target. Okay, now for achieving our target, of course, we need to prepare all the three subjects: physics, chemistry, and bio. And in physics, we were learning about basic maths that is required to understand physics in a better way. So after basic maths, now next topic of physics will start, that is vectors. We can say this is a topic of class 11. That is, it's physics topic only. Okay, but here also we will talk about some maths, but we usually consider this as a topic of physics, not maths. So today we are going to start a topic of physics, that is vectors. Okay, why this topic is required? Yes, vectors first class is there today. Okay, this is the first class of vector. Okay, so why this topic is required? Because in physics we deals with different kinds of physical quantities, and in different kind of physical quantity we have seen some quantity require only the magnitude to completely understand them. Suppose if I ask you mass of something, then you need not mention the direction in which you are calculating the mass. Mass is not related with direction. There is no sense of direction in mass. Similarly, if I ask you what is the time now, then you will not say this time is in 2 o'clock in north direction, 5 o'clock in south direction. So you will not say about direction, you will just give me the time. If I ask temperature of a body, you will just give me the temperature. Its direction is not important. So there are many physical quantity around us. To understand them, we don't require direction, only the magnitude is sufficient. These kind of quantities are called scalars. Scalars, in which only magnitude is sufficient. Only magnitude is required to understand them. Scalar physical quantities are the quantities which require only magnitude to completely understand them. Some examples of scalar quantities may be mass, time, temperature, amount of substance that is mole, okay, then energy, distance, and using distance and time you get speed, that is also scalar quantity. So there are a lot of examples of scalar quantity around us. Okay, I can write down many examples: work, calorie or heat, current, electric current. This is a scalar quantity, but we will talk about something special thing about current. Okay, current is a scalar quantity, but this is a special scalar quantity. Okay, so these are examples of scalar quantity, and there are many more examples, etc. You can think of many more examples of scalar quantity around you. Okay, these quantities do not require direction to understand them. Okay, this kind of quantities are called scalar quantity. But there are some quantities in physics which require both magnitude and direction to completely understand them. If I want to apply a force on a body to move it, suppose I have something here. Let's say we are talking about this water bottle. I want to push this water bottle towards the camera. So should I apply force in this direction or this direction? I want to push the water bottle towards the camera. So I should apply force towards the camera itself. If I am applying force towards the camera, then only the water bottle will be in the displaced in the direction of camera. If I apply force in downward direction, then because my hand is rigidly holding this water bottle, so this is not going down. So force applied in different direction will create different things in this water bottle. Okay, so direction of force becomes important. Direction of force become important. It's a vector quantity. Yes, yes, we will discuss about that, Kumari. Wait. So direction is important for completely understanding the effect of vector quantity. So vector quantity, we may write vector quantities as the physical quantities which require both magnitude and direction to understand their effect. If I want to understand effect of a physical quantity, I need to know the direction of that quantity to completely understand them. Okay, sir, all courses will continue on YouTube for the whole year? No. Okay, so there are two types of physical quantities around us. One is called scalar, which require only magnitude. Others are vectors. Okay, direction is very important. Suppose this is the map of southern part of India, and here somewhere near the coastal line we have Vijayawada, and somewhere here we have Hyderabad. This is approximate location. Okay, Vijayawada is here, Hyderabad is here. If I want to move to Hyderabad from Vijayawada, if I want to go to Hyderabad from Vijayawada, this distance is approximately 290 or 300 kilometer. So I should travel in the direction of Hyderabad to reach Hyderabad. If I go same distance as the distance of Hyderabad, but in opposite direction, I will land somewhere in Bay of Bengal. So direction is very important. If I want to reach a particular point, I should move in that direction only. So this direction is also important to specify the final position, final location. Hence, displacement, example of vector quantities. First example is displacement. Then force. Force is also vector quantity. We have just discussed before, when force is applied in different directions, the effect of force is different. Velocity, yes, is a vector quantity. Force. Then electric field, that will be discussed in the class 12. In the that was discussed in the class 12. Electric field. There are many more vector quantity. Momentum, acceleration. These are vector quantities. These are some vector quantity. Then I can give you more example. Torque, angular velocity, angular acceleration, angular momentum, these are some more examples of vector quantity. So there are a lot of physical quantities which require only the only the magnitude to understand them. These are called scalar quantity. Only magnitude require scalar quantity. Then there are some physical quantity in which direction is also important. This physical quantities effect will be understood only when we know their directions. Okay. Yeah, sometimes area is also considered as a vector. So I can write area here. But again, this is a special vector. Sometimes we consider this as a vector, sometimes we consider this as scalar. Whenever area is in denominator, we will assume it's a scalar. When we are multiplying with area vector, in those cases, we will assume area is a vector. Okay. There are some lot of questions coming here, like will I teach for the boys campus, or a lot of questions are here. But please try to focus on whatever we are learning here. These questions can be asked to administration persons. Okay, that will be better. Okay, try to focus on the physics part here. Okay, so displacement, force, velocity, electric field, momentum, these some physical quantities, these are vector. These are also vector. There is a difference in these two categories of physical quantity, these two categories of vector. Okay, there is a difference between these two. The above list here, they are called polar vector. These are polar vector. And these are axial vector. What's the polar and what's the axial vector? So these are two types of vector. When we when we observe vector quantities, we see that there are two types of vector quantity around us. This group is called polar vectors. There are many more polar vectors, and this group is called axial vector. What's the difference here? Polar vector has a meaning of starting and end point. If a polar vector starts from a point, that is start point, and goes to an end point, so there is some meaning of start and end, like displacement. Displacement is a vector quantity. When I draw a vector, the start point of vector and the end point of vector has a meaning, and the effect of vector is in this direction. So this is the meaning of polar vector. But these axial vectors, they represent rotation. They represent rotation. They represent rotation. Torque is rotating effect of force. By applying torque, if I apply torque on a body, it will start rotating. So the rotating effect of torque, angular velocity is how much body is rotating. We define angular velocity with that. Angular acceleration is rate of change of angular velocity. So these all quantities specify rotation. We will use these quantities in rotation chapter in physics. So this quantities has a very peculiar property that the direction is not specifying anything. They rotate the quantities. They rotate the physical objects. So the rotation effect is shown by this physical quantity. And the rotation effect is decided by right hand thumb rule. If I keep my thumb in the direction of the force, direction of the rotating axial vector, suppose this is my right hand. I am trying to draw right hand here. Okay, I am keeping my thumb of right hand in the direction of axial vector. I am keeping my thumb in the direction of axial vector. Okay, I am keeping my thumb in the direction of axial vector. Use always your right hand for all the good deeds. Okay, we will always use our right hand. Left hand is for something else. Okay, so we will use our right hand. I am keeping the thumb in the direction of axial vector. Torque, angular velocity, angular acceleration, angular momentum, all these are axial vector. Suppose we are discussing about torque. So keep thumb of your right hand in the direction of torque. Then the fingers, they will curl in a direction. In that direction, object will rotate. So this axial vector gives you rotating effect. This is direction of rotation. Or rotation effect. This angular velocity is velocity with which object is rotating. Angular velocity, rate of change of angle. So if you keep your right hand finger in the direction of rotation, then the thumb gives you direction of angular velocity. Let me give you one more example here of axial vector. A body is rotating in a circular path. Suppose this object is rotating in a circular path. It is going like this. Object is moving like this. So keep fingers of right hand in the direction of rotation. Then the direction of thumb gives you the direction of angular velocity. So if angular velocity is in this direction, object rotates like this. Keep the thumb in the direction of axial vector. Then your fingers give the direction of rotation. So this is a special property of axial vector. That their direction directly doesn't give the direction of rotation. We will need right hand thumb rule. What we are using here? Right hand thumb rule. This is right hand thumb rule. Okay. So there are two kinds of vector around us. One is called polar vector, other is called axial vector. Polar vector has some meaning of starting and end point. If they start from one point, end at one point, this is the direction of vector. Polar vector gives you a direction, direct. Okay, displacement is from here to here. This is the direction of displacement. Okay, so polar vector are from starting to end, but this axial vector gives you direction of rotation. So if a vector is in this direction, keep the finger of right hand, thumb of right hand in the direction of vector, the finger will curl in the direction of rotation. So axial vector and polar vector, we have two kinds of vector around us. Is this point clear? We have two kinds of vector. So vectors are physical quantity which require both magnitude and direction to understand them. And in vectors also now we have two categories of vector, polar and axial. So note everything, polar and axial. I hope starting you have noted what are scalar quantity, what is vector quantity, this all thing is noted down already. And examples of vector is noted. After example, write down this polar and axial. Polar and axial, write down these two categories, axial vectors and polar vector. Write down these two categories. And note this right hand thumb rule. Right hand thumb rule. Don't worry if you are having any problem in understanding axial vectors, they will again be taken care in rotation chapter. Okay, so we were discussing about vectors. We have discussed about polar vector. Yes, I can repeat this once again. So we were discussing about vectors. Vectors are physical quantities which require both magnitude and direction to understand them. There are many examples of vector around us. Okay, in vectors also there are two categories of vector, two types of vectors are there, polar vector and axial vector. Polar vector and axial vector. Polar vector will be starting from one point and going to other point. This kind of vectors are polar, in which start and end has some meaning. But axial vector, they shows the rotation effect. Axial vector, they shows the rotation effect. If you keep the thumb of right hand in the direction of axial vector, the finger shows you direction of rotation. So if this is the angular velocity, this is the angular velocity of object. So object will rotate like this. If object is rotating in this circle, the angular velocity is above. Is this point clear? Rotate the fingers of right hand in the direction of rotation. The thumb give you direction of axial vector. There is no meaning of starting and end point. Understood? So we have yes. Okay, very good. Now we will go to next things. So we have just learned about what are vectors. Now we will try to represent them. Note representation of vector. Representation of vector. How to express vectors, how to write about vectors, how to show vectors. Physical quantities required magnitude and direction both to completely understand them. They are called vector. Now how to give this direction as well as the magnitude in a combined manner? This is a big problem for us. How to represent a vector. So we have devised two methods to show the vector or represent vector. One is called graphical way and other is component form. Component format. One is graphical way to represent a vector, other is component format to represent a vector. First, you will learn about the graphical way, then component form will automatically be taken care of. What is graphical way to represent a vector? We represent vector with a line segment and arrow. If I draw a line segment and point an arrowhead on this line segment, this represents a vector. A vector is represented with arrow. Vector is represented with arrow. Length of the arrow, length of the line segment shows the magnitude. I wanted to give the direction and magnitude both. So we have decided that length will be in accordance to magnitude. More the length, more is the magnitude. Shorter the length, shorter is the magnitude. So this length of vector gives the magnitude. And of course, the direction of arrow will give you direction of vector. So graphically, we represent vector with the line segment and arrowhead. The length of line gives you the magnitude of vector, and the arrow gives you direction. Arrow gives you direction. Is this point clear? Okay, length of line segment gives you magnitude. Now, I can draw different kinds of vector here. Okay, suppose I am drawing two vectors. This is first, this is second. The second is almost double in the length of the first. The second is almost double in the length of first. This vector and this vector, they have a relation that second is almost double in the length of vector. So what about magnitude we know? We know because the length is double, so magnitude is double. If the second vector is having double the length, so its magnitude is double. So we can understand about magnitude by observation of length. Okay. Now, the vectors should be named. Otherwise, how we will talk about them? I am saying this is second, this is first. So we will not always name the vector like this. We should give some name to vector. So let us name the vector. Vectors are usually named with English alphabet and arrowhead. English alphabet letter with arrowhead. Vectors are named with English alphabet letter and arrowhead. So let's say this vector is A vector and the other vector, let's say this is B vector. So here I was telling you that A and B have a double length relation. Double length relation. It's not always that we need to use English alphabet. You can use other alphabets also. We can use alpha also. A vector may be called alpha vector, beta vector, alpha, beta, gamma can be also be taken. Okay, we can also use other language, other letters of other languages. Like I can define a vector to be a vector. This is Hindi. It's your choice to choose the alphabet. You can always you can also choose Telugu. You can always choose Telugu. So there are many choices for vector. You can use different letters to represent vector. But the general practice is to use English alphabet. Okay? Okay, Durga Prasad. General practice is to use English alphabet. We usually use English alphabet to represent vector. Suppose a vector is starting from a point and ending at other point. The starting point, we have named the starting point, let's say P, and the other point is, let's say, Q. And a vector is from P to Q. So we may represent this vector as PQ vector. When we know the name of starting point and name of end point, so we name the vector as starting point to end point vector, PQ vector. PQ vector means vector from P to Q. Vector from P to Q. Okay, is this point clear? Vector from P to Q. Okay. Very good. So there are different ways of nomenclature of vector. Different ways of nomenclature of vector. And the length of the vector shows the magnitude. Okay. How to represent magnitude of vector? Now the point is how to represent magnitude. Magnitudes means length. So we represent magnitude with mod symbol. If I want to represent magnitude of PQ vector, I will write that PQ vector within two vertical line. So we read this as mod of PQ. Mod of PQ. This is magnitude of PQ. Magnitude of PQ vector. So two vertical line with vector written in between. This represents the magnitude of PQ vector. If I write this, I means I am talking about mod of A vector or length of A vector. This is length of A vector. So we represent magnitude with mod symbol. So previously here I was telling you that B vector is having double the length of A vector. We can represent this like mod of B vector is 2 times mod of A vector. So because B vector has double the length, it means mod of B vector is double the length of A vector. Can we understand this? What this mod symbol tells us? It tells me the magnitude of vector. Is this point clear? How to write the magnitude of vector? Yes? Okay, very good. Okay. So we have learned here about how to represent a vector. How to represent a vector, how to represent its magnitude. Let's discuss some more terms associated with vectors. Some terms. If two vectors have same direction, like this, like parallel lines, we say these are parallel. Of course, same direction vectors will be called parallel. And if their directions are just reverse of each other, let's say this is A vector, B vector, we say these are parallel. And if their direction is reverse, let's say this C vector and D vector are opposite direction, we say they are anti-parallel. 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 Not opposite, anti-parallel. Anti-parallel. Okay. Two anti-parallel, if they have same length, let's say E vector and F vector here, we know it is given that E vector has same length as F vector. Both are having of same length. Both are same length vector. These two vectors are of same length. But their directions are reverse. They are anti-parallel also. These two vectors which have same length and in opposite direction, they are called opposite of each other. So we will say E vector is minus of a vector. So fourth point we have learned here about negative of vector. Negative of vector. Negative of a vector is just a vector of same length but in opposite direction. So we have learned here about negative of a vector. Negative of a vector means a vector of same length but in opposite direction. Negative of vector means vector of same length just opposite in direction. This is negative of vector. Negative vector. If the angle between two vectors is 90 degree, of course we will say them they are perpendicular vectors. So this alpha vector and beta vector, because this is 90, so they are perpendicular. We'll say these are perpendicular vector. Yes, we will cover everything from basics. So what is negative of vector? A vector having same length but in opposite direction. That is negative. Perpendicular, that is the angle between them is 90 degree. Okay. So we are covering all the basics. Then zero vector or null vector. What is a zero vector or null vector? It's a vector of magnitude 0. We usually define zero vector, we usually write zero vector as O vector. Okay, magnitude of zero vector is 0. So what's a zero vector? A vector of 0 magnitude. Why it is used? Why it is used? Why we use zero vector? So if I add two negative vectors, if I add a vector with negative of it, we say that we are getting zero vector. When a vector is added with its negative, we get zero vector. A question is coming to me. Manish is asking, sir, all opposite vectors are anti-parallel vector? Yes. Opposite means they are just direction in opposite directed. Okay. Right now only YouTube is there. No, for anti-parallel we will not use negative sign. Negative sign will be only used for opposite vectors, negative vector. So when length is also equal, we say vectors are negative of each other. Okay. Example of null vector is this. Whenever you add two vectors of different direction, just opposite direction but of same length, you get a negative vector. When we add two opposite directed vectors of same length, we get zero vector. Two opposite directed vectors are added of same length. If I add two opposite directed vectors of same length, I get zero vector or null vector. Okay, yeah, we will discuss about unit vector now. After zero vector, write seventh unit vector. Unit vector. Unit vector. Unit vector. Unit vector is a vector of magnitude 1. Someone is asking opposite sign means. So negative sign means they are opposite in direction and same in length. It is the meaning of negative sign. See here, I have given you the definition of negative of a vector. A vector, E vector and F vector are negative of each other if the direction is same but magnitude is equal. These two vectors are negative of each other only when the directions are opposite and magnitudes are same. Okay. So now let's go to unit vector. What is a unit vector? Unit vector. A unit vector is magnitude 1. Magnitude 1. Magnitude 1 or unity. Unit vector has a magnitude 1. Unit vector has a magnitude 1. To specify unit vector, we use a special symbol. Let's say I want to specify a unit vector in direction of a vector. We use cap symbol. We read this as a cap. A cap. We will read this as a cap. A cap means a unit vector in direction of a vector. Magnitude of unit vector is 1. They do not represent any magnitude. Their magnitude is 1 or they represent only one magnitude. So why we use them? We use them to show direction. We use unit vector to show direction. We use unit vector to show direction. Is this clear? Unit vectors are vectors of magnitude 1. We define unit vector. We write unit vector as a cap. A b cap will mean unit vector in direction of b vector. B cap will mean unit vector in direction of b vector. So cap means vector is unity. Magnitude of vector is unity. Okay. How to get unit vector? If I want to get a cap, we can get a cap by dividing a vector with its magnitude. By dividing a vector with its magnitude. Vector divided by magnitude will give me unit vector in the direction of vector. Okay. Yes, very good, Sriram, very good. A vector divided by its magnitude gives you unit vector in direction of A. Note it down. How to get unit vector? How to get unit vector? We need to divide a vector with its magnitude to get unit vector. We need to divide a vector with its magnitude to get unit vector. We can also use this equation. If you write mod of A here, so you will get A vector as mod of A into A cap. Mod of A into A cap. What this equation is telling me? This equation is telling me that vector A is equal to its magnitude multiplied with unit vector in direction of A. A question is coming to me, how to get a null vector? I told you to get null vector, you just need to add two negative vectors. If you add a vector with its negative, you get null vector. Is this point clear? When we add a vector with its negative, we get null vector. If I add a vector with its negative, I get null vector. Student's name is, I think, informative vlog. Okay, informative vlog. Please try to write your own name. Your mother, father have given you a good name, so try to use that. Okay. A vector is equal to mod of A into A cap. Mod of A into A cap. It means I can write a vector as product of its direction and magnitude. Mod of A is giving me direction and A cap mod of A is giving me magnitude and A cap is giving me direction. So vector is equal to its magnitude multiplied with direction. See, we have written here, we uses unit vector to go show direction. We use unit vector to show direction. So here is an example that how we are using unit vector to show direction. A vector is equal to its magnitude multiplied with direction. A unit vector gives you direction. Write this equation. This is also important equation. Whenever we need to write a vector, if we know its magnitude and a unit vector in direction of vector, we can always write vector equal to magnitude into unit vector. Is this point clear? Tell me, is this point clear? Yes. Okay, very good. So vector can be derived as multiplication of its magnitude into direction. Okay. So now we have discussed about unit vectors. Unit vectors are special vectors. They represent direction. Okay. We'll cover next point. Multiplication of vector with scalar. 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 If I multiply a vector with a scalar number, let's say I am multiplying vector A with 2, and I am defining 2 times A vector to be B. What does it mean? It means if the length of A vector is suppose mod of A, then the new vector B vector will have a length of double the length of A vector. And the directions is same. Directions is same. When I multiply a vector with scalar, multiply a vector with scalar, multiply a vector with scalar makes length scalar times. That means if you multiply a vector with 2, you get a length double. If you multiply a vector with 3, you get length 3. If you multiply a vector with half, you get half the length. So whatever number you are multiplying, you will get length that much time. Whatever number you are multiplying, you will get length that much time. Multiplying a vector with scalar, we get length scalar times. Scalar times mean if the length scalar number, whatever is the scalar number, that times of length will be there. Okay. And one more property, direction remains same. Direction is same if scalar is positive, but direction changes if scalar is negative, but direction reverses if scalar is negative. So if you multiply a vector with positive number, I am multiplying A vector with 2. So I am getting a new vector whose direction is same as that of A vector. A scalar number multiplied with a vector gives you a new vector whose direction is same. Because direction of A and B is same, we can show direction as B cap. It implies that B cap and A cap will be same. But if you multiply a vector with negative number, let's say C vector is minus 3A. I'm multiplying a vector with negative number. So here the C vector will have triple the length because 3 number is multiplied here. So length will be tripled, but the direction will reverse because of the negative sign. If this was the A vector, this will now be C vector. This will now be C vector. The length of C vector will be 3 times length of A vector. because multiplication by 3, length is now changed to 3 times and direction is reversed. So direction of C cap is in negative direction of A cap. Is this point clear? When we multiply a vector with a scalar number, when we multiply a vector with a number, whatever is the number there, length will be made that much time. If number is 2, I will make length double. If the number is 3, I will make length triple. If the number is half, I will make the length half. So if this is suppose x vector, then half of x vector will be a vector of the half length. A vector of half length. Okay. Whatever number we are multiplying, we will make length that much time. But if the number is positive, if this number is positive, the direction will remain same. But if number is negative, the direction will reverse. Is this point clear? We have also seen earlier that negative of vector means a vector in opposite direction. So negative sign means direction reverses. Negative sign means direction reverses. So we have learned here about multiplication of vector with scalar. Is this point clear to everyone? Multiplication of vector with a number. Okay, we are starting vectors today and we are starting from very basics. So we are just discussing about multiplication of vector with scalar. I hope these points are clear. So let's go to the next slide. So we have discussed about vectors, type of vectors, and just now before multiplication of vector with scalar, we have covered unit vector. Here I have covered unit vector. Okay. So now we will discuss about some special unit vectors. Unit vector in the direction of coordinate axis. Write down unit vector in direction of coordinate axis. Unit vector in direction of coordinate axis. We have discussed earlier that we uses 3 coordinate axes. Sir, write somewhat big letter. Okay. Yes, Sham. I will try that. Now write unit vector in the direction of coordinate axis. Suppose this is our x-axis, this is our y-axis, this is our z-axis. X, y, z-axis are here. We have discussed earlier that x, y, z-axis are used to represent points or positions in space. If I want to specify position in 2D plane, I will use only x and y axis. But for 3 dimension, we will use x, y, z axis. Okay. A vector which is in direction of x-axis and have length 1, it is unit vector in direction of x-axis, unit vector in direction of x-axis. We call this vector as I cap. I cap represent unit vector. This cap represent this is a unit vector. In which direction? In direction of x-axis. So we all have decided to call the vector which is in direction of x-axis as I cap. Unit vector in direction of x-axis, we define that as I cap. Similarly, unit vector in the direction of y-axis and unit vector in the direction of z-axis are called j cap and k cap respectively. J cap is unit vector in direction of y-axis and k cap is unit vector in direction of z-axis. So I cap, j cap, k cap are the unit vectors. Their magnitude is 1. They are unit vectors. I cap, j cap, k cap are special unit vectors. I cap is unit vector along the direction of x-axis. Along the direction of y-axis, we have unit vector j cap. Along the direction of z-axis, we have unit vector k cap. Is this point clear? These 3 vectors. Kondru, no. We have learned here about unit vectors in different directions, x-axis, y-axis, z-axis. Okay. If I ask you what is the direction, what is the angle? What is the angle between I cap and j cap? That is 90 degree. What is the angle between j cap and I cap? J cap and k cap? That is also 90 degree. All these coordinate axes are perpendicular to each other. All these coordinate axes are perpendicular to each other. Okay, yes. Angle between these unit vectors are 90. Okay. So if I cap is unit vector along x-axis, what will be minus I cap? What will be minus I cap? What will be meaning of minus I cap? Tell me. What will be meaning of minus I cap? If I cap is unit vector in the direction of x-axis, what will be minus I cap? Very good. Minus I cap means unit vector in direction of negative x-axis. Negative x-axis. A minus I cap, minus sign means direction reverses. So minus I cap means I cap is in direction of positive x-axis, minus I cap means it is in direction of negative x-axis. Simple. So can you tell me what will 2 I cap mean? What is the meaning of 2 I cap? What is the meaning of 2 I cap? I am multiplying I cap with 2. What will be meaning of 2 I cap? Shiram is saying me 2. SK Anwar is saying me twice length. Very good. Twice length is correct. But complete answer. Magnitude is double. Very good. Length is increased by 2 times. Very good. And direction is along x-axis. So it's a vector. It's a vector of 2 unit length. Because we have multiplied I cap with 2. So length is 2. Length is 2. And direction is along x-axis. I cap means the direction is along x-axis and 2 means the length is 2. So 2 I cap means a vector of magnitude 2 in the direction of I cap. A vector of magnitude 2 in the direction of I cap. So this vector 2 I cap is a vector of length 2 unit and direction is along x-axis. So a length 2. This, let's say this was a vector. So a vector has length 2 unit and the direction is along x-axis. Okay, very good. So if I want to show you a vector which is parallel to y-axis, which is along y-axis and length 3 unit, how I should represent this vector? If I have a vector of length 3 units in the direction of y-axis, how I should represent this vector? Very good, very good. Let's say this vector was b vector. I want to represent b vector. B vector, length of b vector is 3 and it is in direction of y-axis. So we will write b vector as j cap. 3 j cap. 3 j cap. Very good. 3 j cap means vector of magnitude 3 in direction of y-axis. Very good. In direction of y-axis. Very good. Now tell me, if I have a vector in negative z direction, if I have a vector in negative z direction, this is my x-axis, this is y-axis, this is z-axis, and there is a vector in negative z direction. I want to represent this vector. I want to represent this vector. Length of this is half unit and direction is in negative z. Let's say this vector is c vector. How to represent this c vector? How to represent c vector? It is in negative z direction and magnitude is half. It is in negative z direction, magnitude is half. See, I am writing here, it is in negative z direction. Direction is given to you. It is in negative z direction. Okay. Length is half. So this vector c vector can be written as half is magnitude and direction is minus k cap. So we will write this as minus half k cap. Minus half k cap. Very good. C vector which is in negative z direction and length is half. So we will write this as half into minus k cap. Is this point clear? Is this point clear? Yes. Okay, very good. So now we have learned enough thing to understand the analytical or component format to represent a vector. If you remember in start, I have told you that we will represent vector in two ways. We will represent vectors in two ways. One way to represent a vector is graphical way. Other way to represent vector is in component format. Component format. The representation of vector can be done in two ways. Graphical way, we are representing vector with line segment and arrowhead. Length of line gives you magnitude, arrow gives you direction. Now we will learn about the other way to represent a vector, which is in component format. Which is in component format. I can represent vector with its component in xyz direction. Suppose a vector is 2i plus j minus k. I am writing a vector as 2i plus j minus k. It means a vector has a component 2 in x-axis, 1 in y-axis, minus 1 in z-axis. We can say a vector has component of 2 unit. That means the length of a vector in the x direction is 2 unit. Length of vector in x direction is 2 unit. 2 unit in x direction. A vector is component of 1 unit in y direction and component of again 1 unit in negative z direction. Here I am getting minus k, it means in negative z direction. So we can represent vector like this: some number into I, some number into j, some number into k. We should write cap here, but it doesn't matter. It is understood that I means I cap. It's understood that I means I cap. So 2i cap, j cap, minus k cap. It means a vector has 2 units in x direction, 1 unit in y direction, 1 unit in negative z direction. Is this point clear? Meaning of this component form? Are you able to understand this component format? Okay. So in component format, this is an example. If I write general thing, so in component format, a vector is represented as some number, let's say ax into I cap, some number ay into j cap, some number az into k cap. What is this ax, ay, az? These are some numbers. They may be positive or negative number. They are called component of a vector. Ax, ay and az, these are called component of a vector in x, y and z direction respectively. Ax is component of a vector in x direction. It means in x direction a has a length ax. In y direction a has a length ay. In z direction a has a length az. So this is representation of vector in component format. If vector is given in component format and we need to find magnitude in component format. If I want to know the magnitude of vector in component format, that is given by x component square plus y component square plus z component square, root of this. It's very easy. Suppose the vector was like this in the example, 2i plus j minus k. So here ax is 2, ay is 1, az is 1. So component of will be root over 2 square plus 1 square plus 1 square. I can give you an example here. Example, magnitude of a vector 2i plus j minus k. Let us find magnitude of this vector. Magnitude of this vector. So magnitude of a vector will be equal to root over x component is 2. So square of 2 in j cap, 1 is written here. So square of 1 in k cap, Minus 1 is there, square of minus 1. Sign doesn't matter, minus 1 plus 1 both will have same square. So this will come out as root 6. This is how we will get magnitude of vector in component format. Magnitude of vector in component format. Tell me, is this point understood? What is the meaning of component format? In component format, a vector is written like its x component I cap, y component j cap, z component k cap. This is the way to represent vector in component format. We will learn more about component format later on. Okay. Component of a vector in x, y, z direction are ax, ay, az. The magnitude of a vector in component format, we can find this vector like this. Okay, very good. So I will give you one question then. If half I cap plus x j cap is a unit vector, find x. Half I cap plus x j cap is a unit vector. I am telling you that half I cap plus x j cap is a unit vector. X is some unknown number. Find the number x if the vector is unit vector. I am giving you that this is a unit vector. Find the number x. Find the number x. Okay, some students are asking me to show the previous slide. Yes, this was the previous slide. We have discussed here about the component format of a vector. Component format of a vector. Okay, component format of vector is written like this. The magnitude of vector in component format is this. Here I am giving a question. A vector is half I cap plus x j cap. I am giving you that this is a unit vector. Find x. So what is the meaning of unit vector? We must know what is the meaning of unit vector. Unit vector means magnitude is 1. Magnitude is 1, unity. Whenever a vector's magnitude is 1, that is a unit vector. How I should write magnitude of a vector in component form? This vector half I cap plus x j cap. I want to know its magnitude of this vector. How I can write that? I will use mod of ax square. What is ax? Component in x direction, half. What is component in y direction? X. What is component in z direction? Nothing is written in z here. So 0 square. And that must be equal to 1. Because the vector is a unit vector. So we can solve this equation to get x. So here if I square both the side, here I will get 1 by 4x square, 1 by 4 plus x square. And that should be equal to 1. What I have done, I have squared both the side. So this root will go on. 1 by 4 plus x square, that should be 1. By solving this, x square is 1 minus 1 by 4 or 3 by 4. 1 minus 1 by 4 is 3 by 4. How I can write 1 minus 1 by 4? 1 minus 1 by 4, I can take LCM as 4. 1 into 4, 4. Then here I am getting 1. So 3 by 4. Now x square is 3 by 4. It means x could be plus minus root 3 by 2. Plus minus root 3 by 2. Always remember, whenever you have an equation, a square of number equal to another number. Whenever you have equation, square of number is equal to, let's say some other number is written here, a. So this x can be written as plus minus root a. This is the solution. Always try to use both the sign, plus minus. Both may come. So answer is 2 types of answer we are getting, plus root 3 by 2 or minus root 3 by 2. Is this clear? Is this point clear? So it's class time now. 10:15 is the last time for my class. So I will stop now. Today we have covered some basics of the vector. Basics of the vector. I have started with what is a vector. representation of vector. I have started with vectors. What is scalar? What is vector? This current is a very special scalar. It has a direction as well. Current is such a scalar that it has a direction, but it's a scalar number. It doesn't obey triangle law of vector addition. It doesn't obey triangle law of vector addition. We will discuss about current in the next class then. Okay. Vectors are of two types, polar and axial. This is discussed here. After that, we have discussed about how to represent vector, and in the last, we have discussed about graphic analytic component format of a vector. Okay, so I will not take further time. Thank you, all of you. Bye, everyone. Thank you.